Let's take our next question, that is question number 7. Now this question, it belongs to optics. Let's see what question says. Consider a tank made of glass, refractive index 1.5 with a thick bottom, as you can see here, right? Now it is filled with a liquid of refractive index mu. So refractive index of liquid is there and refractive index of glass is given to us. A student finds that irrespective of what the incident angle I is for the beam of light entering the liquid, the light reflected from the liquid glass interface, that is this portion, is never completely polarized. That means this angle, whatever is being made with this vertical line here, let's suppose this is R, it is not satisfying the condition of polarization. So for this to happen, the minimum value of mu is, so what should be the minimum value of mu so that the light gets polarized? This is our main question. Let's see the solution here. So as per the question, we have to maximize R to that extent so that it crosses the polarizing angle's value. Then the polarization will happen. In order for doing that, we have to increase the value of R, and to increase R, we first have to increase I. What is the maximum limit of I which is possible? So I can maximum be 90 degree, right? So as per the Snell's law, I will be writing sine 90 into refractive index of air, that should be equal to sine of R into refractive index of the liquid. From this you will get sine R is equals to 1 by mu. When you see this, you will definitely find a triangle. Let me draw that for you, right? And this. Now in this triangle, this angle would be R, perpendicular would be 1 and hypotenuse would be mu, that is the liquid's refractive index. With this, I will figure out that the base refractive index base would be this. Now, in order to satisfy the polarizing angles condition, tan of R should be greater than equal to mu g by mu L, that is liquid's refractive index. With this, I will get 1 upon, from the tan R, with this triangle you will get perpendicular by base, so it is mu square minus 1, and this should be greater than equal to 3 by 2 divided by mu, right? We just have to put on the values and calculate. From this you will get mu is less than equal to 3 by root 5. So this would be the minimum value which is required for the refractive index of liquid so that the polarization may happen. Let's see which is the best suited option here. So as you can see, option number 3 is the answer to this question. Hope you have understood this one. Let's move ahead and see next question. Now this question, it belongs to current electricity, that is electromagnetism section. The question says a copper wire is stretched to make it 0.5% longer. The percentage change in its electrical resistance if its volume remains constant is. So let's start with the solution. Here the percentage change in resistance has been asked. So what's the formula for resistance? It's rho L by A, rho being the resistivity, L length and A is area. And if its volume is constant, I can also write it like this, V by L. That is, area can be written as volume by the length. Solving this, you will get R equals to rho L square by volume. In any case, the resistivity and volume will remain same. So dependence of resistance is now only on length. From the error method, I can write delta R by R, that is the percentage error of resistance, would be equal to twice the percentage error of length, right? And what is the percentage error of length given to us? It is 0.5%. That means if I put the value here of 0.5, I'll get percent delta R by R is equals to 1%. Let's see which is the best suited option. So of these, option number 4 is the best suited answer, right? Let's move ahead and see our next question. Now let's take our next question. This question belongs to current electricity, that is electromagnetism section. The resistance is shown in the figure. Its value and tolerance are given respectively by. So this is a diagram where there are 4 bands given, that is red, violet and orange. So if they have the value of, let's say P, this is having value Q and this is value X, right? Being silver, it's 10% variation, as you are already aware. So this resistance can be represented as P, Q, into 10 to power x plus minus 10%, right? Where P and Q should not be multiplied, you have to just represent their values. Now what would be the value of red, orange, violet and silver? So we have a very famous mnemonic of these, that is BB Roy from Great Britain has very good wife, and this has been arranged from 0 to 9. So what red corresponds to is 2, orange corresponds to 3 and violet corresponds to 7. So as per our information, resistance should be, instead of red, that is P, I should write 2. Instead of violet, I should write 7 into 10 to power, instead of orange, I have to write 3 here, plus minus 10% variation. And this seems to be 27 kilo ohm. So which is the best suited option here is third option. To answer to this question would be option number 3. Hope you have understood this question very well. Let's move on to our next question, that is question number 10.